Okay, so there was a big update. 0.9.0, or right now there is a 0.1 update for the Steelmaking Expanded. It brought with itself some sister mods. As you can see, there are now three. As you can see, there are now three of them, and I need to do some explanations again. Okay, now we are in an empty world again. Right now, we will try to create a starter setup for the, let me get rid of this, for the steam power. Again, I will not go into detail and show you how to create a huge factory. We'll just do a starter one so that you can extrapolate and create something on your own. First, let me get the blocks I need. All right. Now we have any block. I will use the large red bricks, fluid intake, and a straight pipe. At first, we need to create a water pool where the water for the boilers will be drawn from. To do that, we need to create a 3 by 3 by 3 box. Now we have our box. It should be filled with water. I'll show you how to do this, and I will use the creative water steel, this one. But you can do the same in survival with water buckets. Now we simply fill it like this. Then we place water sides, remove one layer. Now place water again, remove next layer. And here we go. Now we have a 3 by 3 box of water, cube of water. The fluid intake requires this much water for it to function. Obviously, you can find a natural lake and put a fluid intake there, but if you don't have it, you can just build a water reservoir of your own. Now we need to place some anchor blocks. Place this, remove this, and with a wrench you can rotate it to where you want. I will choose this direction, and as you can see, fluid intake says drawing water. If I place the intake in other place, first of all, it will say another intake is too close because they detect proximity and they will not work if too many intakes are placed near each other. And right now it says not enough water below because it checks 3 by 3 box directly below it. So put your intake directly in the center. Here we go. Now we have an intake and a pipe going out of it. But right now, as you can see, there is no water in there because an intake is simply because an intake is just an intake. It cannot pull water by itself. You need to create a pump or replace a pump that will do this for you. There are two pumps available for us. There is a steam-powered one. Here it is, fluid pump that requires a steam engine to operate it, and a manual fluid pump. We will need both of those. So let me create a setup with a steam engine and a manual roundabout line. Now, here we have it. This is a steam engine. This is a manual pump, and this is a steam engine's fluid pump. Right now, we have a line going from fluid intake to this and to this. Steam engine draws water from below, and this is a pass-through block. I place it like this because I want the engine to sit on some solid surface, but you can place simple pipe, it will work just fine. As you can guess, steam engine requires steam for operation, and the steam intake is right here. This one is a condensed water outlet. We can use it to recycle our water, and it can be done just like this. To be honest, I needed to do this just from the start. Now the condensed water from engine cylinder will go straight into the output pipe and join everything else in this network. This is an input steam network, and this is an input water network. Right now it will work simply with a manual fluid pump. I can start pumping with right click. You can see water sounds, and as you can see on the left, I need to look like this. Water starts coming out from that opening. But we cannot spend all day operating manual pump, so let me create a boiler setup to power this engine. Okay, this is the footprint of the basic Cornish boiler, and I have everything I need on my hotbar to complete its construction. The engine is simple right-click constructible. You simply build it and it rises like this. But the boiler is also a multi-block, so we need to complete its construction with other blocks beside the boiler itself. We will start from placing this, probably. Then we need a pass-through bend block. And we need to orient it so it has opening on the upside. Then we can place the boiler itself on the top. As you can see, the boiler has an opening for the water intake on the bottom side. And now we can connect it with these pass-through blocks to allow the water. This is where the water will come from. Now we need to complete the right-click constructible process. I'll do it like this. And now we have the boiler. Cornish boiler is a simple one flue design. It is moderately sized and it can produce only low pressure steam. Fortunately, the watt pattern engine operates on a low pressure steam, so everything should work fine. Now let me complete the construction process itself. Oh, and you can show the projection like this. I simply remember where to place everything. And the outlet block needs to be oriented up. Now, the boiler is complete. As you can see, it has its water contents, steam contents, needs at least 150 liters of water to start boiling. This is because, as you can see, the flue is somewhat above the ground, or above the bottom side or level of the boiler, so we need to fill it up to a certain level for the flue to be able to heat it up. This is exhaust outlet. So the idea of a boiler, if you didn't know, is to burn coal here, and hot air, hot exhaust will come through the flue, this pipe here, and go out through this outlet. This way it will boil the water inside the vessel itself. Right now you can deal with the exhaust here just by placing a chimney block. It should work simply like this. If you have Steelmaking Expanded installed, you can also route your exhaust to a smokestack if you prefer that way. Now let me connect everything with pipes. As you can see, we have our steam line going from the boiler to the engine, and we have the water that the engine will pump going down to the boiler. So this is a cycle, and if you do everything correctly, this setup will operate until coal is burning right here. But the pumping engine will produce a lot more water than one boiler needs, so I added this overflow pressure valve and set its pressure to 0.5 atmospheres, so basically half of the pipe. When there is more water than the half the network volume, then it will go out and just drop on the floor right now, or you can connect this to other boilers to produce more steam and power more engines. To start up this system, we need to fill the boiler first. There are two ways to do this. One way is manual. Now I have a water bucket. I can open the lid and place a water block here. Since this is an infinite water block, all water blocks in the game are infinite, I can just do like this and start filling the boiler with water. This is fast, but maybe tedious and requires you to place water everywhere, which is not optimal, let's just say. This is why we have a manual pump. Manual pump allows you to pump the water like this, and since we connected everything with pipes, the water will go straight into the boiler. As you can see, now it has 66 liters of water. Before it had 50 liters. So now I will simply need to continue pumping until the boiler has enough water. Fortunately, this process needs to be done only once when you start up the system. Then you can use the working pumping engine to fill up all of the other boilers. Now, the boiler has enough water. We can begin firing it simply by taking any coal. The black coal will do fine. We can place it here in the firebox, and then we need to fire it. My rates are speed up, so we don't need to wait full 3 or 5 minutes for the boiler to heat up, but after it heats up, it will start producing steam and rapidly deplete its water contents because the water starts boiling. You can see steam accumulates and the pressure in the pipe rises as well. What engine requires around 2 atmospheres of pressure to operate. So be aware that you may need to continue pumping your manual pump for if the boiler doesn't have enough water. And I will probably need to do that right now. Now I simply operate manual pump and wait for the steam engine to start operating. Hey, the steam engine started up. As you can see, the pipe inside this has 2.6 atmospheres, so it now has enough pressure, but the boiler produces more steam than the engine can consume. So the pressure will continue building up and can lead to catastrophic consequences. We need to add this style overflow to the steam line as well. Let me do that. Now the engine operates again and we have this overflow line. Basically, this pressure valve will monitor if the pressure inside this network will rise above 2.5 atmospheres, then it will start drawing and overflowing excess steam into the atmosphere. This way we can prevent the boiler and the engine from breaking. Okay, now we have a working steam setup. Let me go over everything again. You need a fluid intake, an engine, and the boiler. Everything needs to be connected with pipes, and when you fill up the boiler, light up your coal and achieve enough pressure in the pipes for the engine to operate, everything should start working. Now I will jump into my other test worlds where I have more fleshed out setups, so I can talk about how to actually use all of this. Here we go. This is my another test world where I was testing Cornish boilers for iron production. As you can see, everything here works, for now at least, and we have an endless rain. These are two other submachines that the pumping engine has. One is for mechanical power production, As you can see, it powers the Bessemer converter and the Hellhammers. Yeah, this is how those called. And also air blower. This massive piston compresses the air inside the pipe, so it can achieve enough pressure to blow through the molten iron inside the converter, and also through the ore inside the blast furnace. So this is why we have not one but two operating air blowers here. These ones these are the ones that supply blast furnace with blast, basically. All of this is powered by 5 Cornish boilers, since 1 watt engine consumes almost all steam from one boiler. We have 5 engines, we need 5 boilers. And this is quite coal consuming setup, let's just say. And obviously you need a lot of iron to pipe everything together. But this is the price of the industrial era. Industrial evolution doesn't happen from thin air, basically. This is steam condenser block, by the way. I forgot to talk about it. It allows you to merge steam line into the water line, basically allowed you to recycle steam. This is the only way right now to merge water line or liquid line and a gas line, and this is basically because steam is a gaseous form of water, so this works. Steam under pressure gets injected into the line, into the water line, and everything should work fine. This is where, by the way, water gets ejected, excess water as well. Now we are inside of another world. This is where I've tested the Lancashire boilers and Cornish engines. These ones are more advanced. They operate on higher pressure steam. As you can see, we have 6.5 atmospheres here, and this high pressure can only be reached with a Lancashire boiler. As you can see, it's made of steel. It has a double flue design. If I place it like here and finish constructing, you can see here are the flues. There are 2 of those, which makes this boiler more efficient, and it physically larger, so it produces more steam. But again, it requires more materials and it requires steel. Also, since we reach higher pressures in this setup, we require steel pipes, because iron pipes can burst when pressures reach above 5 atmospheres, but steel ones can hold up to 10. So this is what's required for the boilers of this kind and for the engines themselves, because as you can see, this engine right now throttled down, it requires 5 to 8 atmospheres to operate. This engine is throttled up, it consumes more steam, but it produces more air in this case, and it requires higher pressure of, as you can see, running around this 7 to 8 atmospheres. And these are normal Cornish engines. They operate just like watt engines, but since this design is more efficient, they draw only 16 liters per second, when watt engine consumes 30 liters per second of steam. But again, they run at higher pressures. The Cornish engines also have an advantage, since the pumping engine itself cannot reach higher pressure than the input pressure. Basically, engine transforms input steam pressure into output gas or air pressure. And these ones, since they work on much higher steam pressure, allow you to much easily reach required pressures for the blast furnace to operate. And since engines are more efficient and boilers are larger and produce more steam, this setup is much more efficient in terms of coal. You need only 2 boilers to power everything, and we have an overflow of steam as well. This is the condenser. As you can see here, 48 liters of steam go and merge into this pipe, and also excess steam gets vented through this small stack. Basically, this setup is your next step into the industrial revolution. Hope these explanations helped you somewhat. At least you should be able to create the basic Steam setups now. And as to how to scale this up and how to work with more machines, I will let you to figure out for yourself, because creating complicated setups is fun. I don't know what to say. Basically, good luck, and try to tame Steam power now.